Welcome back to another one of my videos where we test things. And so today we're testing another one of my designs. I actually will be getting into other people's designs at some point. I've got a couple of other amps that I want to test, but for now we're actually going to be testing a preamp today. And it's one of the very first things that I designed, although you'll see it's quite simple. It's a simple design. It actually has some off-the-shelf components in it as well. And I've had a couple of requests to test a preamp instead of an amp. I've designed 3 preamps, and this is the first one. And so there's lots of little things that I would do differently now. I've learned a lot since then, but it's still a really great little preamp. And I'll show you what it looks like here. Here it is. I'll stand out of the way so it doesn't face track me. You can see it's blue. My wife picked this color. I really like how it came out. And you can see it's got some stuff going on there. Got inputs on the front and on the back. Got some nice balanced outputs. And on the top, you can see we've got some transformers here. These are UTC A-20s. Really great line matching transformer. 600 in, 600 out. But they've got a split coil, which I'll show in a minute how that works. But you can see I got lots of little switches, and we'll explain what all the little switches do. This one has something unusual for my designs. It has a rectifier tube. A couple of power transformers there. And I'm going to be changing things up a little bit this time in this video. Usually I wait till the end of the testing video to show you what the inside of the amp looks like, but I feel like that's sort of like saving the best for last or something, and I don't know how many people get that far in my videos. And so for this time, and maybe for all videos forward, we're going to take the bottom off the amp and have a look inside at the amplifier before we even get started, because I feel like maybe that'll pique your interest in seeing how the amplifier measures and why you would even care why the circuit does what it does and things like that. So what is a preamp like this good for? You'll see it doesn't have a volume on it. Basically what this is it's a buffer. So, and it's a balanced output, right? So, and it's got switchable gain settings. And so you put this in between a source and the amplifier, particularly if you want, if you've got maybe a source that isn't particularly low impedance and you want a low impedance output, or if you want to drive a balanced input with a balanced output, transformers are great for that. If you want to add or take away a little bit of gain without adding any noise, transformers are great for that kind of thing. And this has a bunch of other little options too. It's got ground lifts on the input and output, and it's got, you can capacitively couple the input or not. And so it's got a lot of little fun things like that. And so I often run this little guy in between my unbalanced DAC and a couple of amplifiers that I've built that have balanced inputs. So it's cool for that kind of thing. Also, it's just fun because these vintage UTC transformers are great, and they add a little something to the sound. I couldn't tell you exactly what, but there is something nice about this little preamp when you put it in the loop. Maybe it sweetens up that digital source a little bit or something. Could be cognitive bias. I will be the first person to admit that. But I like this thing. I use it a lot. I put it in my system, like I said, a lot. I'll put it between the DAC, and I'll put it between sort of an amplifier that needs to be driven with a balanced input. So that being said, after we look inside the amplifier, we're going to have a look at the circuit, and this is the signal circuit, and then we'll look at the power supply circuit. And that'll probably be the end of the first video. And then the second video is going to be testing. We're just going to test this thing, and we're going to do all the tests on it. We're going to find out what the output impedance is. We're going to find out the distortion and the frequency response, and we're going to just look at the noise performance and all that kind of stuff, and we'll see how I did on this guy. So let's go. All right, let's have a look inside this preamp. And I haven't actually opened this since I built it and initially tested it. And you know, the first thing I see here, the dropping resistor for the Zener there is actually looking a little bit brown. Now this thing has hundreds of hours on it, so that just means that that resistor is just slightly under spec. And so I will probably just leave it. If that one fails, it's not the end of the world. The tubes will just bias down. But that's interesting to see. I like those blue resistors, those metal film resistors, because you can really tell when they've been a little bit cooked. If it were a brown resistor or something like that, you would never know that it had been overheated. But this one, you can see it's a little bit overheated. Here are the transformers. You can see I tried to wire those in with sort of like fancy wiring. I don't know how well that worked. I mean, obviously it worked fine, but I don't know if I would do that the same now. You can see here's the ground lift switch and the output terminals and the load resistors there. And those are the coupling resistors from the tubes to the transformers there. Keep the DC off of the transformer. What else do we have here? Got our test points right there. We've got our tip 50 NPN transistors there, sunk to the chassis. Tube sockets. There's our switchable input capacitance. That's some high voltage filtering right there. You can see we have a nice little shield here between the signal section and the power section. There's the main power supply filter. It's a capacitance multiplier. I did not design that PCB. This was before I knew how to design PCBs, so that's an off-the-shelf component from eBay. Another off-the-shelf component here is the buck converter. That was before I knew how to design a buck converter PCB. So now, this is like a proto version of my modern heater supply, because you see, look, I've got AC low voltage in there from that transformer, filtered, rectified with the rectifier there, buck converted down, and then over here to another set of post buck converter regulators. Then it goes to heat the filaments, and so I have all that on a single PCB now. So it's much smaller, and I designed it myself, so it just, makes you feel better about yourself when you do it all yourself, right? And here's our rectifier. You'll notice that I've actually got diodes on there, so the diodes are actually doing most of the rectification here, and the rectifier is basically just a soft start for the high voltage. There's our power transformer for high voltage right there, and for the rectifier heater. We've got a thermistor there for soft start, and that's basically it. Yep. Pretty good though. Pretty nice, good layout. Got the noisy bits away from the quiet bits. What's this right here? Oh yeah, this is the Zener supply that supplies the voltage, the super filtered voltage for the NPN bases, which is what sets the operating point of the tubes. The tubes in this case being EL84s. So EL84 is not a normal tube for not typical tube for a preamp, but it works great. Alright, hopefully that has sufficiently piqued your interest, and now let's talk about the circuit. Alright, so what's going on here? This is the circuit, and I've got a bunch of stuff on here. This is the very first circuit for a preamp that I had designed, and I was feeling pretty excited about it, so I wrote a bunch of stuff on here. There's also some things I left out. Let's see. And then some things I added that aren't actually in there, so I don't know what I was thinking there exactly, but yeah, there's that. But so things that should be in here. There is a switch that switches in and out of circuit here, a coupling cap at the input. Now, the reason I left it out, I think, is because I sort of realized after the fact that it just wasn't necessary. I mean, what would you ever connect this to that has DC on the output, right? Only if your preamp, only if the source that you're plugging in this thing is just broken. And so I left that out on purpose, okay, because it's just not a thing that you need to have, right? But it is in mine, so I mean, mine technically has a switch that switches in and out a DC blocking cap in the input. I don't have a volume pot. If you were to include a volume pot, this is where you'd put it. Mine simply has a 250K grid leak. And so it's just like the volume pot, except that it's like a volume pot that's turned all the way up all the time. Now, if you wanted to include a volume on this, that's where you'd put it, right there. And if I were to build this again, I think I'd put a volume pot on it. So I think that's why I've left that in there. Let's see. Now you notice over here I've got some instructions about how to jumper the output transformer, the UTC A-20. And that's because the output transformer of the UTC A-20 looks like this. It's and so you've got these, and you can run these in series or parallel, right? And so if you follow the numbers here, I can't remember exactly how I've wired this in this diagram, but in the actual circuit in my preamp, I've got a switch here that toggles both sides between series and parallel. And so that gives me several different levels of gain, and that's going to affect the output impedance, and it will affect, as we'll come to see probably here in a minute, that's going to slightly affect how the square wave comes through, because transformers are pretty sensitive to how you load them. So that's what's going on here, right? Now you notice that what we're doing here is we're running an EL84 in cathode follower mode. And so why did I choose an EL84? I had a bunch of them. I was playing around with them. I thought, hey, I wonder if this EL84 in cathode follower mode would be a good driver for this transformer. And I mocked it up and it worked really well. And so not super scientific here. But we're running this EL84 very conservatively, so I think we're running it at 20 milliamps or 22 milliamps, something like 20 to 22 milliamps. And so it's just really just having a very easy and happy life, that EL84, and so it'll probably last a long time. So what's going on here? We have a tip 50. This is an NPN transistor. We're using it as a current source, and so it's loading the voltage swing at the cathode, so that all of the current swing at the cathode goes through the transformer primary, right? All the AC current, right? All the DC current goes through the current source, but all the AC current goes through the transformer primary through this large capacitor right there. You see it's giant. It's like a 1400 UF cap right there to ground, and that blocks any DC from going through the primary of the output transformer in this case. I've also put a Zener here. The reason I put that Zener there was to save this cap if for some reason the cathode ever shorted to the plate or something like that. That I was hoping that the current would then go through the Zener, and I would be able to sort of like notice the amplifier wasn't working right and unplug it before it destroyed my wonderful output transformer. Maybe that would work, maybe it wouldn't. I don't know. When I designed this, I didn't know that much. I think I'd probably do that differently now. I think I might also put the coupling cap between the cathode and the transformer, but I don't know if it makes a big difference, but I think that's another thing I'd probably change. I think I put it here just because I thought aesthetically, and just from sort of an abstract point of view, it was nice to have the cathode connected directly to the transformer, and have the DC blocking cap on the other side. And I think I still feel that way kind of, but I think that just as a precautionary thing, I might put it over here instead. I don't know. I don't know if I'd change that. I have to think about it more. So like I said, both the primary and the secondaries are set up with switches to be run in series or parallel mode. And also you can see I've got it set up for balanced output. Now balanced output with a transformer is excellent because you can basically connect this without any reference to ground to your balanced input. And then you can also say here, you've got the ground, the shield here, and it can be connected to the shield, but also it can be lifted so that it only is connected AC. So if you have a DC current path through your shield somehow and you're getting a ground loop hum, you can flip this switch and it still is going to ground out high frequencies that might get picked up by the shield, but it's not going to allow that low to DC frequency sort of ground loop path through your shield. And so also transformers are great if you've got a balanced output like this and you want unbalanced out. All you have to do is tie one of the legs of the transformer to ground. And so I have an interconnect here. We're going to be testing it in sort of unbalanced mode because my They're going to work best for our testing purposes here. And so I have some interconnects that I plug in, and they literally just have a jumper between 3 and 1 or something like that. It'd be between 3 and ground or something like that. I think it's between 3 and 1. And so that works out really well. So that's what these transformers were made for. You know, to buck ground loops and sort of balanced runs across your studio, things like that. Really cool. And these transformers are just top quality. I got them on eBay a long time ago. I mean, a long time for me. That's I think I built this in 2019 or something like that. And they're just really, really great. Now, the prices for these little buggers have skyrocketed. I think I paid, you know, $40 or $50 each for them. I don't think you can find them for less than $100 each these days, and I think that's probably a good deal as it is now. Anyway, let's look at this current source. So the reason you can run a regular old NPN transistor as a current source is because the way that transistors work is they're naturally current sources. So their collector is sort of naturally very high impedance, and so all you have to do is you have to supply the base with a voltage that's 0.6 to 0.7 of a volt higher than you want the emitter to be, and then place a resistance after the emitter there. And so you know there's always going to be that 0.6 to 0.7 of a drop between the base and the emitter. And so if you apply a voltage here that's just 0.6 or 0.7 of a volt higher than you want across that resistor, that's what you'll always get across that resistor, right? And so then you just put a resistor there and you measure the voltage across it, and you know your current. And so the NPN will then drop the rest of the voltage to supply whatever the voltage is here that is needed for the current to go through that tube. So in this case, we've got 10 volts between the grounded grid and the cathode here, and that's being dropped completely across this NPN transistor. And we're getting our reference here. I don't know if I show this on the other, yeah, I show this on the power supply, so we'll see where we're getting this reference voltages over on that power supply. But basically I've got 10 volts here, nice and filtered. I've got a 10K and another 10K pot, and it grounded there. And you can see you can adjust it here, and you just test across this 10 ohm resistor until you get your 0.2 of a volt, right? That allows you to know that you've got your 20 milliamps going through that. And so that's how you set it. And it's very, very, you don't have to adjust that. Like after you set it, basically you're done. And in fact, if I were to design this again, I would just design it such that the pot wasn't needed. You know, like you don't need to have that there. This isn't the sort of thing like as the tube ages, blah, blah, blah. You know, it's not like that. Like a current source, once you get it running, then it just stays that way forever. You know, like they're very, very reliable in that way. So that's what that is all about. What's this little guy right here? We haven't talked about this. So this is a ground lift at the input. So this allows you to either have it grounded through a switch, or if you're having a ground loop problem, you can break the ground loop by inserting a series 10 ohm resistor. And so ground loops are very, very low voltage and high current, and that's why they couple strongly and cause that hum. But because they're very low voltage, high current, a small resistance like a 10 ohm breaks the ground loop pretty effectively. And also I've bypassed that with a little cap there. That means that it's still going to be effective for shorting high frequency noise and such that's picked up there at the shield for the unbalanced input, right? Right. And so it's nice to include one of those. Like every now and then you'll find that it's in a situation where if you flip that switch, your noise gets considerably better. Most of the time it doesn't do anything, but every now and then you're just happy it's there, right? And so it's not very much skin off your back to put it in, so that's why I put it in. Also, it just makes the buffer, the preamp, a little bit more versatile. You know, you could drop it into a situation where it's got a ground loop problem, and by flipping these switches, you can fix 90% of them, right? So that's what's going on there. The LA84 here is in triode mode. I've connected the G2 to the plate. You can see it's got 10 volts on the cathode. That's important because that's our headroom to swing, right? Like it can't swing down more than 10 volts, right? And so it can swing up and down, presumably 10 volts is less than that because you need some drop across the current source. So it's, you know, our output headroom is going to be up and down 8 volts or something like that, which is perfectly fine. We're only looking to get 2 volts or odd out of this thing, right? Because that's typical for a preamp. It's nice to have a little headroom above that, but you don't need a ton of voltage there. That's why you don't have to lift the grid and put a big resistor here and drop 100 volts there for a preamp. It's completely unnecessary. A current source and a grounded grid is perfectly fine in this situation. So let's have a look at the power supply. All right, here is the power supply. And like I said, there's some things I would change here. There's things that I've left out. One thing that I've left out that you might have noticed that when we were looking inside the amp is that I've got a pair of diodes here that look like this. Like that. So that's one thing that's different from my little drawing here. Unnecessary, obviously. The rectifier will rectify that perfectly fine, but in this case I put those in there. And I don't recall exactly why I did that. Maybe it's sort of a little safety feature in case the rectifier decides that it wants to short out or something like that. Doesn't seem very likely, but who knows. And this little guy right here, I don't have this blocked off here, but I should. It looks like this, I think. This is an off-the-shelf item that I got on eBay, right? It's a capacitance multiplier circuit. This is before I knew how to design PCBs, right? Before I had done that. So this is something I just got on eBay, and I just knew it was a filter. And so this is like my current version of this is a better filter. It's a better design. It's got different features that are better. This is fine though. It's really good off the shelf. It's sort of where I started, right? And so I knew that this was an excellent filter, so I put it in here, and then I added another little, bit of RC right there. Right, so we started out with 270 and 270, and after all this, running up with about 300 volts, and I'm estimating, I guess, 60 milliamps is what I'm saying there. That seems a little high. Because I think we got 22 milliamps per tube, and then another some amount of milliamps here. So maybe it's there. I think it's probably less. Probably less than 60, probably more like 50 if I had to guess. And also we see here, this is the supply voltage for our base for our transistor, for our current source. And if you'll notice here, this guy right here, that's the one that was brown, slightly brown in the amplifier. And so that one is dissipating a little bit more power than it's happy with. And so at a future date, maybe that one gets swapped out. But you can see why it's dropping the difference between 300 volts and 11 volts, right? So it's dropping a lot, and it's probably doing it at about 5 milliamps or so, because 5 milliamps is what you need to run that right there. And it would be easy to find out. You just 300 minus 11, then you would just divide it by 120K to get the milliamps. And I would do that for you right now, but my phone is not around here, so you can do that if you want and find out exactly how much current I've got running through there. And then you can see I've just RC the heck out of it. Probably a lot more than was necessary. Like I said, this is one of my first designs, and I wanted it to be really quiet. And you do need the bass to be quiet. You need, it's a little amplifier there. If you put a signal at the base, you're going to get something at the collector, and it's going to go right into your output. So that's no good. So I went a little bit nuts there and just filtered the heck out of it. But that's fine. If I was doing this again, the first thing I'd do is I would dump the high frequency from the Zener right here with like a 1 UF film or something like that, because there's a little bit of noise that might come out of there, although it's probably getting lost in all these RCs. So I might eliminate an RC and put a film cap there if I was doing this again. But still, this is a fine way of getting a little reference voltage. No problem. So that's the high voltage. Rectifier, capacitance multiplier, RC, and that's going to be supply for our EL84s. Not too much going on there. Now we've got a bunch of funny stuff going on here for the heater. I wanted this to be a preamp. I wanted it to be really quiet, and so I went a little bit nuts with the heater. supply. And so what I've done is I've rectified it. I've filtered it with a 6800 UF cap, which is big. I've dumped high frequency here with this 0.1, right? So that's like switching frequency of the diodes or something like that. Then I've run it through a buck converter. Now a buck converter is a switching supply. A switching supply efficiently drops a high voltage to a low voltage without dissipating heat. And so you'd usually think, okay, if you wanted to figure out how much heat something is dissipating, you'd measure the voltage drop across that, right? And you'd measure the current, and you just do voltage times current, and you come up with a power number. Well, this doesn't do that. This is, you can imagine like a switching converter is a little guy who's turning the switch on and off over and over. And so when the switch is on, it's allowing all the voltage and current through, right? And so it's not dissipating any power, like a switch. And the switch is off, there's no voltage, it's dropping all the voltage, no current, right? So that's why switching converters are so efficient. All right, so this is a little switching converter that I got off the shelf. I've since learned how to sort of design my own PCB with that, so I'm not using off-the-shelf component anymore. But this switching converter converts it down. Then I filtered it. Then I filtered some high frequency because these switch a certain frequency and that will bleed in. So I've got high frequency filtering here with a little inductor. And then I've got another cap, so I'm really going crazy here. And so at this point I'm down to 7.5 volts, and then I've got a pair of low dropout 6.3 volt regulators. And another thing that I'd change here is now I know, I just put these caps in here because it's what I had, but you don't need 330 UF caps after a regulator. That can actually be bad for the regulator. In this case it's fine, they've been just fine, they're surviving okay. But you really only need about a 10 UF there, right there, 10 UF after a regulator, right? Anyway, so you can see that by the time the DC gets all the way over here, it's incredibly filtered, very, very quiet DC supply. And like I said, I've got a board now that I've designed that does all of this on a single board, and that's the heater supply that I've been putting into amps for a while now. Over a year, and it works great. Right, so that's the power supply. I forgot we got a thermistor over here for a little bit of soft start. Yep, like we got this extra. This is like a vintage. What is it? Thor Darson transformer got on eBay. A vintage little 12.6 volt transformer, which looks great on the top of the chassis. And so that's what's going on. So that's it. In the next video, we're going to test. We're going to just find out, how did I do? How does the preamp do? All right. See you next time.